Okay, so I believe we can start. I believe you can see me. Could you please confirm that you can see me? Okay, have a confirmation. So hello everyone. Our greatest pleasure to have you on our webinar, another series of Chemspace webinars. So today we're having Organics and Steve Brough from this company. So a few words about the organization words. So we will have all the attendees in the listening only mode. So if you would like to ask a question, there is a question box down there. So you're very welcome. And in the end of the presentation, I will definitely give your questions to Steve and myself. Also, if on some occasion your colleagues couldn't join us today, the webinar will be recorded and it will be available tomorrow on our YouTube page. So it is forever there. So in any time you can watch us. And also, if there are any questions after the presentation, you also can reach out with myself, Yuri, or Steve at all times. So I think that would be basically it. So I will start with the camps. I would like to have a few words tell you about a few words about Chemspace, what we do, just to remind you, and then I will give the words to Steve. So Chemspace is a platform of small molecules, building blocks, reagents, screening compounds, and fragments. So far, we have almost half of in-stock building blocks and reagents, and also we have more than 6 million in-stock screening compounds. And the saying that, on the other hand, we have billions of make-on-demand blocks to those in-stock chemicals that are available. And this make-on-demand analogs to be synthesized in a reasonable and acceptable period of time with a great success rate, more than 80%. Also, Chemspace we have procurement and sourcing services, so we can basically source from any supplier from the world just for you. And also we have a fee-for-service based and have this multiple suppliers and very transparent price policy, and having logistics suppliers on all the places of your shipment. Also, we do virtual screening programs, the catalog of 6.2 off-the-shelf compounds. Also, a few words about our website, about chemspace.com. That is an ultra-fast. We have having a multi-billion database. You have to have a great search option, and we have such one in which includes substructure, similarity, and text search, and also the file inputs. And with that, in just a couple of seconds, you can receive the results to your queries. Also, text search includes normal and well identifiers, such as you can search class numbers, MFCD, chemical names, IUPAC names, or suppliers IDs, or Chemspace. And also you can import files just having those identifiers in one place, or an SD file, and just upload it and have the results back. Also, we have another part of our website is the access to the InMeans real space made with a collaboration with Biosolve IT, which give you access basically to almost 18 billion compounds. And it works pretty simple. So you just draw your query molecule and run the search button over the green one over there, and just within a couple of minutes you receive your results on your email address that you have registered on Chemspace. Also, I would like to mention that Chemspace provides punch-out integrations with your SAP systems, and it's basically it's chemspace.com, but customizable just for you, and it is suitable for such systems as Coupa, Reba, or many others, Jagger, and other systems that are typically used in companies. And it is secure and awesome, very nice tool for having having a secure one and having a chemspace.com on your computer. Also, several words about Chemspace that we have a lot of suppliers on board, and just having gathered them on our umbrella and on our platform, we're trying to provide our users and customers the best and the most transparent way to purchase chemicals from one place. And having said all that, today we'd like to welcome our guest, our speaker, Stephen Brough, also chemist by training, who graduated from Nottingham Trent University. Also used to work in ASINT back in the days, and almost more than 8 years working with Key Organics as a business development manager. And today the topic would be basically understand that it would concern Key Organics chemistry solutions such as synthesis, building blocks, fragments, and PROTACs. And we now I would stop sharing my screen and give the words to. I'll ask you to focus on the presentation. So, Steve, can you?
Can you change the presenter to so I can upload?
Yeah. Now you can. I believe you now you can present your screen. Yep, it's nice. Yeah.
Yeah, that's a very nice picture. It's reminding me when we can go on holiday.
Oh,
so that's been cool too, actually. So, okay, good afternoon, everybody, and many thanks for Oleksii and Chemspace for inviting us and organising this webinar. Probably take about 20 minutes to run through the slides, and then there'll be time for any questions at the end. So there's my contact details should anybody want to revisit the webinar afterwards and have a look at my email address. Basically, Key Organics is a chemistry CRO established in 1986. So we're based in the UK at the southwest corner in Cornwall, which is a very nice part of the country, as you'll see from those photos. I'm actually based in the Midlands, so I'm doing business development. I'm travelling around normally, so I haven't been able to get down to Cornwall for the last year, which is a shame, but hopefully soon. You can probably divide the company into two parts. So it's all owned by Key Organics. So on the left-hand side, I've got Key Organics Chemistry Services, and that's custom synthesis. It could be something more collaborative in an R&D project. We can work on a contract basis. We have invested quite a bit of money in the process R&D side of things, so we can go up to probably about a kilo scale. On the product side, so the BIONET catalogue, that's split into several categories. So intermediates and building blocks, fragment libraries, which we've been busy in for many years now, screening compounds, and the collection is probably now over 210,000 compounds, I think. So majority of these are in stock. Where do we fit into the discovery map? I mean, this is drug discovery, but it could equally apply to agrochemicals. So we can get involved right at the early stage in lead finding, and that could be provision of screening compounds, fragment libraries. We can also do procurement as Chemspace can. And we can provide building blocks for DNA encoded libraries. So a little bit more about that later on. As you move from the lead fine into the lead optimization stage, then obviously, FTE kind of chemistry comes in, but also it could be provision of an advanced intermediate, which enables library work at the client's premises. So there's a range of things that we get involved in there. And that kind of goes through to candidate selection, but then you start to think about preclinical scale up. So that might be route development, it might be synthesis of some stable label compounds for PK studies, it could be impurity profiling from a process, and that could be identification by synthesis or just fishing it out by HPLC. And again, we can supply the building blocks for those manufacturing processes. So I'd split the talk up from here on into a couple of different categories. So we'll just talk about the catalogue first. So one of the areas is intermediates building blocks. There's a couple of examples there. Go to 116,000 building blocks at the moment, and that's split up into various pack sizes. One of our challenges really is how to stay relevant and ahead of the competition, particularly from low-cost countries. So what we try and do is innovate. Some of that is internally, but increasingly we collaborate with both academia and also other companies, which you'll see in the next few slides. So this is an example of some internal chemistry, making fluorinated building blocks, which are always quite popular. So we do some internal innovation, but probably not as much as we do externally now. Another example of that was, we noticed a few years ago that the popularity of sulfoxamines was very, very large, and we set about making some of these building blocks in-house, as well as sourcing some through partners, and they proved a very popular line, and that's ongoing. So people are still publishing a lot on this sort of area in different functional groups, which is sulfoxamine-like. There's a lot of work going on in that area. We also partner up with companies that we like, and I see Vaclav's on the call. Hi. And CF Plus is one of these that we picked up with 2 or 3 years ago now, and that was exploiting the fluorination chemistry. So just highlighted a couple of things on here that they're currently very strong in, and that's the fluoroalkyl azides, really useful sort of reagents, really. And there's a few examples of the ones that are in stock on there. There are also expertise in that area, so other ones can be made on demand. And everyone who's done heterocyclic chemistry will know the utility of these types of molecule. This kind of fits in with our strategy of having useful building blocks and things that people want to actually buy and put into their programs. Oh, there you go. I put an animation there, I didn't realise. Another example from Vaclav's group is using those azide reagents to make triazoles, right? I mean, triazoles are a ubiquitous building block in both drug discovery and agrochem. So again, these are really useful building blocks, and beyond the ones that are actually available now, again, it's the usual thing, other ones are available, and that really applies to a lot of our offerings. That we can make things like sulfoxamines, but we often get customers coming back, well, I like that one, but can you make me this one? And so it's where the two areas sort of combine, really, the catalogue and the custom. So it's a way to link that together. With academia, so we have several ongoing applications, collaborations. These guys at University of Southampton, they have published in JMed Chem about manipulating aliphatic fluorination, manipulating log-P, which is obviously important in drug discovery to get the properties of your molecule right. So you can go away and look at that paper, but some of these compounds will be coming out quite shortly. Actually, they're getting on with synthesizing some of these molecules, and so again, it's just trying to stay ahead of the game, really, and come up with really useful blocks of work. Another collaboration around some sort of novel chemistry is through an organisation called Red Brick Molecular, who work with academia, University of Sheffield and Leeds here in the UK. And this was a nice body of work from Peter O'Brien around some novel pyrazoles. And again, we're we're listing those. And again, it is, yeah, you can have these, but you can also have other ones as well. Another example, so it's not just groups of compounds, we're also interested in novel reagents as well. And the guys at Oxford published on this recently, Michael Willis's group, who's done a lot of chemistry around this area, published on this, and so we can offer that compound as well, and that's a really useful intermediate reagent. I actually live in Nottingham, so the University of Nottingham, you wouldn't be surprised, is one of our key collaborators, and we've done several things over probably the last 4 or 5 years, but this is one of the more recent ones. So they developed a Mitsunobo catalyst, and the advantage of this is you don't end up with a whole load of triphenol or phosphine oxide to get rid of. So it actually makes it a very clean process for doing Mitsunobos. Changing track slightly, so we're quite well known for providing fragment libraries. So my colleague Andrew has been putting this together over many years in collaboration with the Brough Institute in the US and a company called NMX, who did a lot of the NMR work behind this. This is separated out into several sets. So we have a general fragment library, which is the premium library, which comes with solubility measurements, QC by NMR, and lots of accompanying data. We also have a fluorine library if anyone's wants to screen fluorine fragments by fluorine NMR. More recently, we've come up with a small collection of covalent binding fragments, a small collection of bromine, and some halogen-enriched ones as well. And as it says at the bottom, you know, we don't just sell the entire libraries, although we do have sales there. People are often just adding to their existing fragment libraries, so they'll be topping up or improving the diversity of those libraries by buying additional compounds. So we can do both of those things. In terms of design, for the covalent binders, we restricted it to an amine set which followed the rule of 3, and then enumerated those with the acrylamide warhead, which gave us a diverse set. And we've had some interest in this, but currently talked to a couple of academic collaborators in this area to really push this on further. So I expect some more news in this area. We have a relatively small collection of biochemicals. So by biochemical, I mean things that are of known activity. And people often buy these, and they may want to validate a screen, get a competitor compound, and just to see what the activity is, or they may be looking to repurpose. So there's probably around 1,500 of those that we have, and we do try and add more to that collection. And this can be sorted by indication or pharmacology, however you like. In addition to that, we have some low molecular weight screening compounds, and probably about 55,000. And again, we can cherry pick all the plate formats, including 384 well. We can supply DMSO solutions. We can augment what we have by looking at other people's databases and then formatting those. So it can be a one-stop shop for screening compounds. And we're quite happy to do small collections. So if people come with a substructure, you know, we can put together a smallish library of 1,000 analogs to screen. So we've done that several times as well. DNA encoded libraries is obviously a very hot topic, and given our experience in sort of plating out fragments and screening compounds, we can also apply the same to supplying you know, thousands of building blocks filtered by functionality, as you can see on there, for people who are engaged in DEL work. So we've gone through and looked at the chemistries and what's compatible with DEL, and come up with several lists. So we can format that you know, however we like for the customer. And all this is really linked to our compound management service. So basically, the text is quite small, but it basically said we can format into any desired format the client likes, and that could be in a restock exercise. It could be a compound collection enhancement exercise. We've done those. We can also supply sets of building blocks such as boronic acids in reaction-ready format. So, you know, we supply a millimole weight amount of 20 boronic acids in microwave vials, for example, and that can go straight into some robotic chemistry. but this also applies to screening sets and the fragments as well. So a little bit about the chemistry services. I won't go and read through all that. We've kind of covered that. So, but some of the areas that we work in, the main thing with the top line is we can be flexible. So we work with our clients in the way that suits them best, and they're different. You know, it could be different if it's an academic group to a spin out to a big pharma company. They all might want different approaches, and that's fine. Some of the activities we do, hit to lead libraries, route scouting, bit of scale up to, like I say, about 1 kilo. We often do novel and advanced intermediates for clients, stable labels. Also already touched on the impurities and metabolite stuff, but you can do that. Yeah, I think the bottom line is we've got a big history in small molecules, but more recently, oligos and related large molecules are coming more into play, and we've gained some experience in that. And obviously, as part of the title suggests that we've been involved in PROTACs to quite a large extent as well. Yeah, that's just really repeating what we've already covered in terms of the process R&D, but some nice pictures of the type of kit that we invested in 2019 and 2020. And, you know, we have a program of investment in the scale-up area for the next 3 years. So, you know, we're going to add in some reaction screening kit and more automation as we go forward. Yeah, that's the list of the kit. I don't think we need to go through that. So, then I guess most people will be familiar with the area. It's been quite hot for 2 or 3 years now. So I've stolen this graphic from one of the papers, but it's just in case anybody isn't aware of the area. Basically, you have 3 areas. So you have your ligand, your ligase ligand, and then your ligand of interest at the other end, and then you have a linker, which can take many forms and many lengths. So what we trying to do is build up a collection of commercially available PROTAC intermediates and linkers and actual final compounds. So that's a database now of over 2,300 compounds, and that is a mixture of linkers and ligands, and we can sort of do that. We can sort that any way we like. We've also in the last 3 years done quite a number of custom synthesis projects around the PROTACs area, which has given us some good experience, because although the molecules might look, they're large, they might look fairly simple, the chemistry doesn't always behave itself. That's how chemistry is, right? So yeah, I think we've gained some good experience there. Within those projects, I think we've done some of the design work, and things to consider here is, you know, what chemical point of attachment are you going to consider for your ligand of interest? So you might have an active compound, you want to see if it can go into a protein degradation process. How are you going to attach that? What's the chemistry going to be? Where's it going to be? You need to think about linker length and nature. So often what people will start, and you'll see a lot of it in the literature, is the simple pegylated ligands, but then you need to think about later on maybe making that more rigid, which might give you more activity. You may want to make that less lipophilic in terms of its physical properties. So there's a lot of work going on, I know, in industry and in academia around those. There's also quite a lot of work around novel or different E3 ligase motifs. So, you know, that's another thing to consider there. Which one do you use? You know, which one is the most suitable for scoping out your process? And of course, chemical tractability is always the stop or the go. I mean, if you can't make it, it's no use, right? So that also needs to feed into what you're thinking about. We've certainly had some dealings with people who are looking at computational aspects of this as it relates to physical properties and absorption, etc. And there's a group at the University of Turin who've been very helpful there. Just put that reference on there. If anybody's interested in the area, this is a really good paper to have a look at. Definitely, that's the group from the University of Turin. I'd definitely recommend a read of that. So we've added to our knowledge by sort of looking at, there's a couple of really good databases, one PROTACpedia and the PROTACDB, so from the Weizmann Institute, and you can gain a lot of data from it really collates everything that's together, and you can start to think about the linker light. Obviously, at the moment, PEG linkers or alkanes make the majority, but I'm sure that will probably change over time. You know, as people look at different ways to get into this space and where the novelty is and how to improve physical properties. So again, I would definitely recommend, if you're interested in the area, to have a look at those two databases and a couple of references that I've put up there. So if you're doing a PROTACs project, how can we help? Well, in the first instance, we could supply some off-the-shelf building blocks. Could be a single compound, could be a range. We could supply some known actives if you want to just have a look at what's already out there. We can certainly do custom synthesis and scale up to a point, you know, depending on the chemistry. If anyone's looking for a longer term arrangement, you know, we feel we have the experience to do that. I think we also have some experience in relating to design as well. So I'll be happy to have a talk to anybody who wants to get into this area. And I think I was pretty much on time, 20 to 25 minutes. So do you want me to change presenter? Back to you.
No, I guess it would be okay. Just we can stay with the slides. It's okay. Thank you, Stephen. It was a wonderful presentation of yours. So
thank you.
Attendees, if you have some questions, you can paste them into the question box down below under the webcam. You're very welcome to do that. It'd be much appreciated. But since we're waiting for the attendees to have the questions, I have a small question for you. How frequently do you update the catalog in terms of new molecules? I mean, the new coming, new synthesized ones. How frequently could that be?
That's a good question, and we used to do it more often, but because we're adding so many compounds, it tends to be quarterly. So we've just done an update, and the next one won't be due till August now, I think. Well, that's not quite true, because I did get Gary. We've got a collaboration with a company who've got some natural products, and I did get him to add those right now. So in general, it's every 3 months. Yeah.
Okay. Yeah, it's pretty widely spread, this kind of frequency in terms of catalog updates. Okay, and what would be the typical compound weight? I mean, and what could be the largest? Because I mean, the nanomolar solution is always available, but I mean, in terms of the largest like amounts that could be shipped to the customer.
It depends very much. You know, we can operate up to probably a kilo amount, but a lot of that depends on the chemistry of the compound, really.
Okay, gotcha.
There's a couple of questions in the question box. So Dimitro has asked me why the slides are saying strictly confidential. They're not strictly confidential. This is just because I've used a template that's used for different things. So don't worry about that. I'm not presenting anything that you can't share. That's fine. In terms of bench chemists, we've got last count we're a small team of 12 chemists. So they are split up in a couple of guys who do the scale up. We have people who've got particular skill sets in the oligos and the stable labels, and then we have people with other skills like doing parallel chemistry. It's very much horses for courses, but I would say that based where we are, we have a very low turnover of chemists. So the vast majority are very experienced. So it's a good team. Paul Eastwood said the sound is very bad with echo. Well, I'm sorry, I didn't hear an echo from my end. I don't know what we can do about that.
Yeah, I think that was the start of the presentation. I hope it runs well further. Also, it's a kind of painful question nowadays because of the situation worldwide. But I mean, I assume that you operate worldwide and you send like to any location, and so like Asia, Americas, Europe. But what is the expected like time difference? I mean, and not time difference, time difference in the shipment you experience now. So it's like twice or like 30% additional time to the estimated. How do you handle? How do you see that one?
I think there's been a couple of times where it's been delayed going from the UK into EU countries. Well, I don't think we've seen a particular problem going to the US or Japan. That doesn't seem to have made any difference. I think it was in the early days that
Oh yeah,
perhaps people didn't understand how it was going to work. So yeah, in Japan we have an agent or two agents actually. In the US we sell directly and through a couple of partners, but mainly directly. In the rest of Europe, yeah, it's direct. You know, delivery is pretty quick. So I have another question from Dmitry Yarahov. I hope I pronounced your name correctly. Do you plan to enlarge DL blocks by using different combination of functionality? Yeah, absolutely. We're always looking at that, and getting die and tri-functional building blocks in there is definitely something we want to do more of. Is there any more questions?
I think we can wait for another couple of seconds, maybe somebody.
Yeah, so we've got another one. With typical delivery time for in-stock compounds for EU, it used to be next day. I would probably say a couple of days now, just to be on the safe side if it's in stock. It depends on the time of day you order it. You know, if you order it early in the morning, you might get it next day. US probably 2 to 3 days. That's not really a problem.
Okay.
Like I say, you know, if people want to get in touch with either you guys at Chemspace or me directly, my email address was on the first slide, so you can go and grab hold of that. You can find me on LinkedIn anyway. It's not a secret, you know. Please do get in touch after the meeting if you've got any questions or you want some more information. That's fine.
Yes, absolutely. So I believe we can, with that being said, that we can start closing the webinar. And I must say that I'm very grateful for everyone who had an opportunity to join us today. So thank you very much. And the video would be available tomorrow morning on the YouTube, and we will share the link with you on your email addresses. So the colleague of yours would be able to see it, and you can share with them. And also, I strictly recommend to subscribe to our social media to be in touch and to be updated on what's going on and what's in the news. So I can see things a lot. Yeah, thank you very much once again for joining. Thank you very much, Stephen, for an amazing talk. So yeah, we'll be in touch.
Thanks for organising it. It's much appreciated, and yeah, we're quite happy to do another one on another topic at some point. Thanks for everybody for staying as well. Not boring you to death.
Yeah, thank you so much, Stephen. So said that, I will start shutting the webinar. Bye everyone. Stay safe.
Yeah.
Stay.
Yeah. Bye everyone. Bye.